Hello, Year 12s. So today we are going on to the next chapter. This will be the last chapter before you go off on your summer holidays. And this particular one is called amines. So you can see from my mind map here that we will be talking about different types of amines. You might have already come across primary, secondary, tertiary, and so on. We'll define amines. We'll look at some exercises on naming amines, its physical properties, chemical reactions, and how you can make amines as well. During the course of this slide, I will also be giving you some time to do some extra exercises that are not in your textbook. Okay, so let's amines chapter 27.1. This is what you were asked to do as part of your pre-reading. So I'm going to now start with the first one. So before we actually go on to amines, let's look at something you learned at GCSE. You might have come across the word, the chemical ammonia right from GCSE, and by year 12, we looked at the sort of shape it is, why it has a particular shape, and so on. So you should know roughly about 5 facts on ammonia. Take time to just pause this video and recall any 5 facts, whether it's on the shape, the structure, its reactivity, anything like that on ammonia. Okay, once you're ready, unpause the video for the answer. So the obvious one is that nitrogen has a lone pair of electrons, and these repel the bonding pairs of electrons. This turns the ammonia into a shape that is known as trigonal pyramidal. It has a bond angle of 107 degrees. Now, because of the lone pair on nitrogen, ammonia is one of those few molecules that can do hydrogen bonding. The lone pair again makes the molecule alkaline or basic because it is able to accept H plus ion in a neutralization reaction. Next, the final property is that it is a nucleophile again. Because it has got a lone pair of electrons, it is able to form dative covalent bonds. So really, this is a combination of GCSE work and even Key Stage 3 work, because we're looking at neutralization reactions, as well as Year 12 work with nucleophilic reactions. Right, so let's get on to the chapter ahead. Define amines. Amines, like you've come across this really for derivatives of carboxylic acids. Amine is a derivative of ammonia, where one or more hydrogen atoms have been replaced by a carbon chain, so an alkyl chain, or a ring. So it could be aromatic. So very similar to carboxylic acids, forming derivatives of carboxylic acids such as acyl chloride, amide, and so on. Okay, in this particular case, it's ammonia that is having one or more of its hydrogen atoms replaced to form derivatives called amines. So define aliphatic amine. This is when the nitrogen atom has at least one straight or branched chain, alkyl chain. And an aromatic amine is when the nitrogen atom has at least one aromatic ring. Now, I know I've said this before for ammonia, but it is crucial that you show your lone pairs for all amines. And I know it's not something maybe Google Images show, so my images will not show it. Sometimes textbooks won't show it, but it's vital that whenever you see a nitrogen atom, you show the lone pairs. And I know I stressed the importance of lone pairs when we did hydrogen bonding in class a few weeks ago, where I said to show hydrogen bonding, you must show the lone pairs, whether it's on nitrogen or oxygen or fluorine. Always show the lone pair. The hydrogen bonding dots come from the lone pair to the hydrogen atom on the next atom. And also, while we are on hydrogen bonding, to always show the delta pluses and delta minuses. So a little bit of revision from year 12, but again, emphasis on lone pairs. So below you can see the three different types of aliphatic amines. You've got primary amine, secondary amine, tertiary amine with all alkyl chains. They're all aliphatic amines. And then I've also given you an aromatic amine, which has an aromatic ring there. I do understand we haven't done aromatic chemistry yet. We will be doing benzene rings when you come back in September. So anything with a ring, a hexagonal shape, is aromatic amine. We will learn, I will talk about the fifth type of amine. So you've seen the four there. I will talk about the fifth type of amine at the very end of this recording. Okay, so the next question was give examples and name primary, secondary and tertiary amines. Now, these are what I call symmetrical amines, and they can be very simply named. So symmetrical amines have a very simple naming system. As you can see there, if it has a methyl group, then you've got, if it's got a methyl group, then it's called methyl amine. If it's got two methyl groups attached to a nitrogen, it's called a dimethyl amine. And if it's got three methyl groups attached to a nitrogen, it will be called trimethyl amine. Okay, so it's a tertiary amine because it's got three hydrogens replaced. It's got this one, the dimethyl amine is a secondary amine because it's got two hydrogens replaced and so on. So I think these are fairly straightforward. You've got to count the number of carbon atoms. If there are two carbon atoms, it'll be ethyl amine. If it's three carbon atoms, then it's propyl amine. But all of them on that nitrogen atom will have the same number of carbon atoms. Now, what happens if you've got two different numbers of carbon atoms on a single amine? So when it is unsymmetrical, like in secondary and tertiary amines, we are going to use a slightly different way of naming it. When you come across an amine like the ones below, you can see that the nitrogen is attached to, it's a tertiary amine. Okay, it's a tertiary amine because all three hydrogen atoms in ammonia have been replaced with an alkyl group. But they are different alkyl groups. So how would you name them? The first thing you do is you pick out the largest, longest alkyl group. So if we look at the first diagram on the left, the longest alkyl group has three carbon atoms. It's highlighted in blue, three carbon atoms. So it's propyl. It's going to be a propyl amine, and that will go at the end of the name. That's your suffix. The two branches now, because we've identified the longest chain, the two branches are going to go in front, like you learned in year 12. The two branches are two methyl groups, okay? And to show that they're two methyl groups, we are going to put the prefix dimethyl. And to show that they're attached, both of them, to a nitrogen atom, not a carbon atom, like you'd usually expect in organic chemistry, but this is uniquely to nitrogen atoms, we then give it the name N, capital N, dash dimethyl propylamine to show that the two methyl groups are individually, separately attached to the nitrogen atom. Okay, so we're going to do the same thing again with the structure on the right. On the right, the largest alkyl chain has got 6 carbon atoms, so it's hexyl. It is not a straight chain, it is in a circle. So we say cyclohexylamine. Once we've identified cyclohexylamine, we can now do the branches. There are 2 branches, methyl here on the left and an ethyl on the right. They are both attached individually to the nitrogen atom. So it's N-ethyl dash N-methyl. Right, year 12s, I think it'll be a good idea for you to make notes on anything that is not in your textbook. So things like this, if it's not in your textbook, please add it on so you can make flashcards using this information as well. Okay. You are going to be naming these 2 chains. This is your exercise. Please name these 2 secondary amines. Pause the video and name the amines. Right, so the first one, you need to identify the longest chain. Now these diagrams are not ideal, by the way, because it's a combination of skeletal, display, all sorts of different formula in one, but this is something I found on Google and I'm stuck with it. So the first thing you do, as always, yes, put those lone pairs highlighted on the nitrogen atom. As you can see, most of my images do not have the lone pairs, so even if I forget to remind you, please remember to put those lone pairs in. Once you put the lone pair in on the nitrogen atoms, count the number of carbon atoms. The longest chain for that structure on the left is 3 carbon atoms, so it's going to be 1, 2, 3, so it's going to be propyl. So it's going to be propylamine as the ending or suffix. You've got 1 branch here, which is a methyl group. So it's N-methyl dash N-propylamine. Then we are going to go on to the next structure. The next structure is, and we're going to count, remember the lone pairs again, we're going to count the carbon atoms again, 1, 2, 3 carbon atoms on the right, so this is going to be a much longer chain. So your ending or suffix is going to be propylamine, and your branch is going to be N-ethyl. So your full name is going to be N-ethyl N-propylamine. Please remember the dashes. And yes, you can see there is a slight error in the PowerPoint, which I'm going to try and amend before I send it to you. Okay, so we are now going to, now that we've named amines, we're going to look at some of the properties of amines. And we have already, to be honest, talked about one property of amines. We've said that yes, it is basic. Okay, amines behave as a base, but why do they behave as a base? If you think about sodium hydroxide from year 7, ammonia from GCSE, they're all bases. And now that you're at A level, we are going to go into a little bit of detail about why these things behave as bases. Now, bases react with acids from year 7 in a neutralization reaction. And the way they react as bases with acids is that because bases like amines have a lone pair of electrons, they can very easily accept H plus ions, which we also call protons. So the lone pair of electrons accept the protons to make a salt, just like in year 7. And the sort of bond it forms you learnt about in year 12. The lone pair of electrons is donated to the H plus in a dative covalent bond. So 3 points here. Amines are basic because they have lone pair of electrons. They accept H plus ions to make a dative covalent bond. So that is the property of amines we are going to look at. We are now going to do an exercise. You are going to be doing an exercise. And again, a reminder right from year 7 through to GCSE that ammonia or amines plus the acid makes salt. So I want you to think year 7 to 11 now, okay? So in all 3 examples, we've got a base and an acid. These acids you've learnt about right from year 7. Bases are different. They're year 12, 13 work because they're amines, okay? So you have to do a number of things. You have to be able to identify the name and draw these aliphatic amines. And you also need to remember the formula of hydrochloric acid, sulfuric acid, and nitric acid. And finally, you are going to be writing the formula of the salt that you're making. Now, before you start on this exercise, can I just say, I know you will be able to do the formula of the 3 acids. For the amines, could you please draw a structural formula, okay? Not skeletal, not display, but structural formula for the amines, plus the acid, arrow, the salt, okay, which is going to have some plus and some minus in it. Go back to the previous slide if you've, to get an idea of what it might look like. Right, you may pause the video and try out this exercise. The answer is on the next page, but it'd be really good if you could try this out, get it wrong if need be, and then I will give you the answers on the next slide with all the names as well. Okay, so here are your answers. The first base was propylamine with 3 carbon atoms plus HCl to make propyl ammonium chloride. Okay, remember that example I gave from GCSE. Ammonia plus hydrochloric acid makes ammonium chloride. So you can see the only thing that's changed here is the propyl that I've added on. Everything else rest of the name is pretty much GCSE. Next example was ethylamine plus sulfuric acid, which makes ethyl ammonium sulfate. Now, because sulfates have a 2- charge, okay, it's very important that we have that it's neutral because it's a salt. It's a neutralization reaction. It's a salt. So we have twice of these to make it 2+ of the ammonium. Methylamine plus nitric acid makes methyl ammonium nitrate. So make sure with the charges that you are that it's a neutral salt. That's the only thing I'll say apart from that. Okay. Right. This is your next exercise. Okay, next exercise, put these in order of base strength from the most basic to the least basic. Explain your answer. Which one of these five structures do you think will be the most basic? Which one do you think will be the least basic, and why? Think about what a base means. We did this in just a few slides ahead, and we said a base is anything, in this case, with a lone pair that accepts a proton to make a dative covalent bond. So in a way, you are trying to identify which of these has the most potential to attract a H plus ion to form a dative covalent bond. Please pause the video while you write your answer. The answer is on the next slide. Okay, so we know from before that amines are basic because they have a lone pair of electrons that can form a dative covalent bond and with a H plus or proton. So the most basic is going to be the tertiary amine because it has 3 electron donating groups, making the nitrogen atom a lot more dense, electron dense. Okay, remember the nitrogen atom already has a lone pair on top of that. If it's got 3 alkyl groups, all 3 alkyl groups are going to donate electrons towards the nitrogen, making it very electron dense. Now, next will come the secondary amine because it's got 2 alkyl groups. Then it'll be the primary amine because it's got 1 alkyl group. And then it's going to be ammonia. It doesn't have any alkyl groups, but it does have 3 hydrogen groups, which will do a bit of electron donating. But the least basic is going to be the aromatic amine. And again, year 12s, you will not know this, but you will come across the word delocalized later in year 13. In fact, probably in the first few weeks of year 13, you will come across this word. So we will talk about this again. So aromatic amines are the least basic because what happens is that lone pair on the nitrogen in the amine is spread out over the whole structure, and that is what it means by partially delocalized into the benzene ring. The electrons, the lone pair electrons, move all around the benzene ring and are delocalized and spread out like margarine across the whole structure. So unlike the other 4 structures where you've got electrons pumping into the nitrogen atom to some degree, in this case, the lone pair is absolutely spread out over the whole structure. So how about amides? Are these basic or neutral? Write the question. Give us an answer. Pause the video. So this is an amide. If you've forgotten about it, we've come across amides before in carboxylic acid derivatives, and they are not basic, they are neutral because the lone pair of electrons on the nitrogen atom are pulled towards the carbonyl group, towards the oxygen, and it is delocalized. Localized means in a particular area. Delocalized means spread across the area. You would have come across the word delocalized in year 10 for GCSE. So it's spreading out of the lone pair of electrons. So I cannot emphasize for this topic the value of a lone pair of electrons. You must always have that lone pair on that nitrogen to help you out. Okay, we're coming on to the end of these slides. Describe and explain reactions to make primary, secondary, tertiary, and aromatic amines. Ammonia acts as a nucleophile in substitution reactions. Why does it do that? What can be used to react with ammonia to make ethylamine? And for this reaction, and I know you've done the reading, ethanol is used as a solvent. Why do you think this might be? Why not use water? So let's look at this reaction to make amines. So we have looked at naming amines, we've looked at the properties of amines, we've looked at how basic it is and so on. We are now going to look at how to make amines. So how can we make some primary, secondary, tertiary, and aromatic amines? Here we're going to start off with ammonia acts as a nucleophile in substitution reaction because it has a lone pair of electrons. I know I've said this many times. It's only because it is relevant to nearly everything I have talked about. So with that ammonia, we are now going to make a primary amine. To make a primary amine, we are going to be using a haloalkane. It could be chloroalkanes, it could be bromoalkanes, it could be fluoroalkanes. But the important thing is that we react it with ammonia, showing the lone pair of electrons. There is the mechanism. Please be careful with mechanisms. Show the delta plus on the carbon atom. Show the delta minus on the Br atom. Draw your arrow from the lone pair in nitrogen towards the carbon, heterolytic, making a dative covalent bond, heterolytic fission between the carbon and the bromine. The bromine comes off and you are now left with a salt. Okay, so the next thing that happens is that because you have now made what is known as ethyl, because it's carbon CH3, so ethyl ammonium bromide, which is a salt, okay, you have to now turn that into an amine, because the purpose of this exercise is to make amines. So to make that amine, you need to add sodium hydroxide to your salt. Once you add sodium hydroxide to the salt, you get two extra byproducts. You get sodium from the sodium hydroxide reacting with the Br minus to form sodium bromide. You get the OH minus from sodium hydroxide reacting with one of the hydrogens from NH3 plus to make water, and then you're left with an NH2. So then you're left with an amine, an ethyl amine. So you can make amines by reaction of ammonia. So that's quite easy to remember, isn't it? Amines from ammonia. But to bring in that alkyl chain element to it, okay, like propylamine or ethylamine or so on, you need to use haloalkanes. So to make propylamine, you need to have chloropropane, okay, or bromoethane to make ethylamine, and so on. So ammonia and a haloalkane to make a salt, but that salt has to be then reacted with sodium hydroxide to make the amine together with the sodium bromide and water. Now, one of my questions was, why do we use ethanol and not water as a solvent for this reaction? And the reason being, going back to year 12, is that with water, the haloalkane, your reactant, can be hydrolyzed into the alcohol. We wouldn't want that. We want the haloalkane, so we do the reaction in ethanol. Now, there is one other thing to remember, which I will go into greater depth in the next few slides, and that is you need to use a limited amount of haloalkane. So the ammonia is used in excess, the haloalkane is used in limited amounts, because if you have lots of these haloalkane, then these haloalkanes will substitute all the hydrogen atoms in the ammonia to make secondary and tertiary amines. So if you want a primary amine, which is the purpose of this slide, it says primary amines are made with, then it's vital that you use only a limited supply of the haloalkane. Okay, so I know I've talked about this before, but this is going into a little bit more detail about why ammonia is used in excess to make primary amines. It is also a slide that can be used to explain how secondary amines are made and how tertiary amines are made. So the reason why ammonia is used in excess to make primary amines is because the nitrogen donates its lone pair of electrons to make a dative covalent bond with the carbon on the halogenoalkane. In this case, it's chloropropane. When the chloropropane is in excess, this nucleophilic substitution is repeated many times to make secondary and tertiary amines. To prevent this, so that only primary amines are made, ammonia is used in excess. I know I've said that in the previous slide, but what this slide also does is to tell you how secondary amines are made. So if you have propyl, you've already got primary amine here. That's your primary amine. You're adding more chloropropane to it. So a little bit more excess of chloropropane. You get your dipropyl ammonium chloride. You're going to add sodium hydroxide to it to make your secondary amine. Sodium chloride and water made as your byproducts. Now that secondary amine, once it's made, if there is even more of an excess of chloropropane, or you add more, then you can make your tertiary amine. So there you go, tripropyl ammonium chloride. You add sodium hydroxide to it to make your amine, sodium chloride and water. Please remember the water at the end. It has gone off the slide. Okay, so we now know how to make aliphatic amines. And we know to make aliphatic amines, we start off with ammonia. Amines sound like ammonia. So start off with ammonia, but the thing about amines is they also have alkyl chains. We introduce those alkyl chains by adding halogenoalkane to it. If we add excessive amounts of halogenoalkanes, then all the hydrogen atoms in ammonia are slowly substituted to form primary, secondary and tertiary amines. But now we are going to go on to something completely different. We are going to figure out how to make aromatic amines. Now this structure on the left is something called nitrobenzene. Okay, this structure on the right is known as phenylamine. Yes, I know it doesn't sound systematic or logical, There are historical reasons, and again, we'll look at all of that in year 13. But for now, please remember this is nitrobenzene on the left, phenylamine on the right. And we are going to learn about a second type of reduction method. You have learnt about NABH4 in the previous chapter. We are now going to look at a second reduction method used specifically for this, which is tin. SN is tin, and hydrochloric acid under reflux. So tin and acid are used in reflux to make the ammonium salt, which is then neutralized with sodium hydroxide to make the phenylamine. There's a quick revision slide next. Here is your revision slide. We've come across NABH4 to turn carbonyls to alcohols, aldehyde to primary alcohols, ketones to secondary alcohols. This is the second reducing agent that you have to remember, which is tin and hydrochloric acid reflux to make nitrobenzene into an aromatic amine. Okay, so this is the final one, which is explain the reactions of amines. We know right from GCSE and maybe even year 7 and 8 that ammonia is basic. What is made when ammonia reacts with HCl? What is this reaction called? Right, now we're getting on to year 13 work. Write an equation for cyclopentyl amine with HCl. Make a go of this yourself. So think about, what do you call reactions right from year 7? What do you call reactions where bases react with acid? It's the same thing here because amines are bases. Ammonia is a base. These are think about what that reaction is. Now draw your base. This is the difficult bit. Cyclo means a circle. Pentyl means 5. So it's a circle of 5 carbon atoms that is attached to an amine. That's your base. Plus HCl. What are you going to make? The answer is on the next slide. Okay, so predictably, bases react with acids by neutralization reactions. Your base is your cyclopentyl amine plus your HCl to make your ammonium chloride. Okay, so there is your salt in a neutralization reaction. Again, crucial, you have your lone pair on all the nitrogen atoms there. So, this is your final slide. Amines make ammonium salts with acids by neutralization because amines are bases. They react with acids by neutralization reactions to make salts. Now, ammonium salts are what we call quaternary amines because a nitrogen is attached to 4 groups in this case. We've come across primary, secondary, tertiary, which are 3 aliphatic amines. We've come across aromatic amines. This is now your quaternary amine because nitrogen is attached to 4 groups. Now, the lone pair on nitrogen is used in dative covalent bonding to make the 4th bond. So there's been a lot of repetition here.